self-sustaining. So it has to make its own air, makes its own water, carries its own food, and it has to also operate as a warfighting machine as well.
The submarine has to be able to withstand underwater strikes and explosions. And so computer simulations put the hull through extreme testing to ensure it will keep its crew safe if attacked. With around 600 people involved in the design process alone, this is one of the largest concentrations of such expertise in the world.
It's the most complex submarine we've ever built. It's got sort of like 250,000 miles worth of cable on board the boat. It's got something like about 25,000 valves. We have to produce more than 100,000 drawings. So all the drawings originate from our computer-aided model.
It took 4 years to design the Astute, which will contain more than 1 million individual components, designed on a computer, but built by hand.
My job is a steelwork team leader. Started off as a shipwright in 1982 and worked my way through the business. I've been in this shop now for about 12 years. This is the place where all the submarines start out life. This is where the raw plates come in by road. The wagon's back into the shop. The magnet crane removes them and puts them into the piles.
Using a plasma cutting machine, each plate has carefully designed patterns burnt into them.
When each plate comes off the burning machine, what we do, we leave a small stitch of metal which stops all the individual pieces falling out on the floor. Peter the burner, what he's doing now is cutting through all the little stitches so the piece parts will fall out. They all go where they need to be built in the right time, just like a massive airfix model.
The steel that makes the hull is shaped and rolled until the massive sections are completed. Peel away the special coating and the pressure hull is simply a watertight tube capped at both ends with tanks that fill with water to help it dive and surface. And finally there's a fin section on top. The hull is made of 8 separate steel sections, each around 11 metres in diameter. The boat is 97 metres long and when finished weighs 7,400 tonnes. The huge sections are made in a different part of the yard and when completed need to be transported down a public road to the building where the vessel is actually put together. At 260 metres long, 58 metres wide and 51 metres tall, this building is one of Britain's biggest sheds.
This is the DDH, which stands for Devonshire Dock Hall. The submarines are built in here because it's where all the top secret stuff is, where people can't see, so it's housed and it's hidden. It's where the magic happens, I suppose.
The Astute is the first class of British submarine in which sections are worked on vertically. This allows easy access for the team before the section is turned the right way up or shipwise.
Right, what we've got is a unit like this and we'll lower it down till it's on its 2 turning shoes at the far end there. What we'll then do is rig Frank up to the shock crane up here. We'll start turning it over like this so it's rolling on the 2 turning shoes. My job's just a second set of eyes, just to make sure that everything's running smoothly. because I'm the appointed person. If anything goes wrong, it's me that gets it in the neck. We're at a critical stage now of this turn where we've transferred the weight of the unit onto the mobile crane. The mobile crane is holding the load. We're now going to de-rig the shop crane and re-rig it onto these eye plates on this lower side of the unit. It's a critical point now. If either of these two cranes fail, well, I wouldn't like to be standing here, I'll put it that way.
A submarine packs in 3 times more machinery and equipment than any surface ship. But most of the back of the boat is taken up with the nuclear reactor, the engine, and all the different backup systems.
We're now in the diesel generator space. Should we lose a reactor at sea, then we would rely on these diesel engines to provide the electrical power for running the minimum of equipment that we need to live as human beings. If you really need them at sea, then it's a bad hair day and you've got some problems, yeah.
For a submarine to operate effectively, it has to be virtually undetectable. To do this, machinery is isolated from shocks, noise and vibration.
This mounting here is an example of how you decouple the noise or the vibration generated from the diesel engine here from a sensitive piece of equipment. So this is basically, you can see here that this allows this piece of equipment to move. We expect the Astute class to be one of the, or if not the quietest submarine in the world, and one of the reasons for that is of course the technology we employ on here to prevent the vibration being transmitted to the hull.
Today, Boat 3 is taking shape as some of her biggest sections are being moved into position. Submarines take on water to help them dive, and a lot of it comes into the streamlined 270-ton forward end construction. This unit also houses the submarine's sonar equipment. Active sonar works by emitting a pulse of sound and then calculates the amount of time it takes to hit an object and bounce back, which determines the distance. But the Astute will normally use passive sonar, which simply listens to the sea to detect and identify objects. It's claimed this technology is sensitive enough to hear a boat leaving New York Harbour from Southampton. The other end of the submarine is capped with the after end construction. Weighing in at around 230 tons, this also takes on water when the submarine dives and houses the mechanisms that control the submarine's rudder and propeller shaft.
My name's Dave Park and I work for the production services team. We're in charge of all major movements in the DDH, do all the heavy lifting, do all the shipping of modules and moving all the units. We're setting up now ready to move the aft end construction up to the after dome. There's 4 transfer cars. They can actually pick up to 250 tonne per car. We're moving 39 metres and it's a metre a minute it travels. Everything's away, so we're ready for this. We're ready to go then, boys. Green button, let's go. Thank you. The team what I've got have been working together for over 20 odd years, so they know the system inside out. I mean, we're used to a lot heavier. You're used to something like 600 tonne putting together against another unit. This is a baby. This is a little baby. As we get 6 foot off the units, we have to put people inside. So we bring more people in on this. We've got to watch as we go up towards the dome so that we don't hit that unit. As you can see, we've only got 3 inches to go now. Now we're going to go on an inch button where we can actually do it an inch at a time. Inch it up, Tony. One at a time, Matt. Just the last inch now, boys. That's it, thank you. We can't do anything more with the transfer system. That's as close as we can get it.